Can you see the presentation?
Yes, we can.
Okay. Hello to everyone. Before I start, I'd like to mention that this is my first semester of master, and I don't have a thesis yet. Even I don't have a subject. I didn't decide yet. And recently I've been assigned to reading 2 books, and this is influenced by these 2 books. It was an interesting experience, and I've decided to make my presentation on this subject. It's about artificial intelligence and general artificial intelligence, and what comes next is superintelligence, and how to achieve these phases, how the humanity will get there and pass through there. Since Homo sapiens evolved apart from our cousin apes, we developed and became the ruling species of this planet. After building up the intelligence, few of the questions we wondered and discussed was, what is intelligence? What is consciousness? What's going on inside of our brain? How our conscious formed? This was some of the questions that we have wondered since we have the conscious. After some time passed and the year came to mid-90s, some of our frontier scientists and philosophers foresaw the AI, which inevitably will become the common future of us. The expectation of machines matching humans in general intelligence have been since the computers have been invented in 1940s. This is not a new idea. It's old as the history of computers. So speaking of machines matching humans, to be clear, what is that? It's a machine having abilities of common sense, learning, reasoning, planning, and so on. Since then, the expectations to achieve this have been unchangingly 2 decades. In every few years, these expectations and put forward, and the 2 decades roughly hasn't been changed since now. And still there are many specialists expecting this will happen in 2 decades. So we honestly don't know and can't make an accurate prediction. Sometimes a problem seeming very complicated turns out to have a very simple solution, or vice versa. It wouldn't be surprising if a group of hackers in a basement achieved this in a couple of years, or a consortium of institutions could just lay a foundation, maybe decades later. But the indicators show that once we achieve this stage, it's like a roller coaster climbing the top of the rails before it starts going downwards after flipping the peak. And the excitement starts after that. We are still in the climbing phase, maybe at the most steepest part. But unlike the roller coaster, after flipping that peak point, the terrain won't stop any soon, even won't slow down. It will go all the way after superintelligence beyond. Because the next thing will be superhuman level and beyond, uh, we can call it intelligence explosion. So we can compare this with economical growth of humanity as seen in the charts below. These are the linear global domestic product charts of the world. The left one shows last 10,000 years in 2,000 years slice. This is the zoomed out version. And the right one shows the last 500 years in 50 years slice. This is the zoomed in version. It's obvious that GDP was about zero. We can see it's almost zero since 1950 till 1950s. And in 1950s, it exploded, we can say. But before these things to happen, we have to consider so much things. There are so many tricks, considerations, traps, and dangers in this path. If we talk state of the art, nowadays there are so many researchers and achievements on this area. And there are too many commercial products as tools or softwares. AI already outperforms human intelligence in many domains. But the key point is here domain. That's far from reaching human level. We know that AI has been beaten many of the world champions in several games, including famous game Go, with the known largeness of possible moves and harnessed of the planning strategy. I won't mention the other games as all we know them. And other than games, today we have way too successful machine translation technologies that can translate to a large variety of languages. And the programmers of these languages even don't need to know any of that languages. These concepts of AI, although they are impressive, but the way they work is narrow. A chess playing AI can't do another thing. A self-driving car can't do anything other. That's the condition for all AIs we use now. I forget to press the slide. And here's some of the examples about state of the art. As I mentioned, there are very talented robots as Boston Dynamics and Honda's Asimo, and there are space instruments, equipments that help us exploring the space using AI and machine learning techniques. There are medical equipments for diagnosis or for surgical operations. They support our doctors. And personal assistants like Google's Assistant or Siri and many others. There have been some improvements and continuing about analyzing visuals, recognition, controlling behaviors, and interacting with a natural environment with the aid of improving hardware. but with addition of common sense and natural language understanding and reasoning to this, with a concept of all these achieving a full human level succession stands for AI complete problem. We have to achieve these all matters all together. This is the AI's general AI's problem. This is a duplicated slide, sorry. So how will super intelligence form? How will we achieve that stage? So we said that human level intelligence and beyond is inevitable. There should not be just one way for this. How will it happen? There are several possible paths, and it may be achieved by more than one of them. It's obvious that having more than one way, it will end up with increased possibility of achieving. One of them is artificial intelligence. In this concept, not all the ideas are new. We know some of them. One of the oldest is Alan Turing's child machine that he put forth. The child machine, the idea is that instead of trying to program a mature AI, he offers to produce a child level and educate it. There are several approaches on this based proposal. One of other approaches is using genetic algorithms and recapitulate evolution in a controlled way and put just the good mutations in it. Another suggestion is in enlightenment of the advances in neuroscience and cognitive psychology, we can inspire from functioning of the brain without imitating it. Seed AI is one of the ideas that's again a variation of Turing's child machine. Is defined as a sophisticated AI capable of improving its own architecture, initially by try-fail way and assistance from programmers. But at the later stages, it will improve by itself. One of the ideas under this concept is recursive self-improvement. And the other main idea is whole brain emulation. In this approach involves multiple apart disciplines and technologies. The software would be produced from a modeling of a whole brain constructed with sufficient resolution. To do this, a detailed scan of a human brain is created. This could be done by autopsy-like ways. Then it is cut into thin slices to scan layers. The slices is scanned by maybe electron microscopes. After that, the raw data is used by image processing softwares to construct the 3D model of the neural network. And finally, the neural computational model is implemented by a powerful computer or more than one computer. If it is successful, then a digital reproduction of a human intellect is constructed. Of course, this will include if we're speaking of a human brain, it will be including the personality of that individual and the memory of the subject. By this way, we don't need to find the answers to questions of human cognition, how the human cognition works, or how do we program an AI. These are the advantages, the easy parts of this main approach. And there are some other advantages. Once we have gained this, we have successful results of this approach, we can copy this and alter this and play with it to improve. Another approach is biological cognition. This method is involved of enhancing the functioning of biological brains, not developing computers of super intelligent, but increasing ourselves in intelligence. This is not directly depending on the technology. This method is about changing to manipulating the evolution. This method concerns some political and moral considerations, and uh, it's time consuming. We need to have a complete mapping of genes, and after that we can select and alter the genes and breed better generations and repeat this process in each generation to create superhuman from today's human. Another approach is brain-computer interfaces, and this is about implants and augmentation. By this approach, in addition to curing many diseases or disabilities or amputations, we can boost our brain intelligence. But there are challenges for this approach. I'd like to show a 3-minute video here, if I may. Can you hear and see?
I can see it moving. I don't think I heard it.
Now I paused it.
Okay. Yeah, the audio is not coming, but that's okay. We can watch it and read the subtitles.
And this is an example of early stages of augmentation and implants. But there are many handicaps of this approach. We know that brain does not store memory the way the hardwares do. We need to figure out to extract meaning of the raw data and read from brain of and we need to figure out to convert this raw data into meaningful information, and the vice versa of this process. But yet another difficulty is uh, each brain develops its own way of storing the memory. Once we decoded one person's brain activities, that does not help to with the other people. Each brain is individual, and another one is biological neurons has speed of 200 hertz, while a microprocessor has 2 to 3 gigahertz of frequency. This is faster than power of brain, more than power of 7. The brain has very low capacity of sequential operations, but hugely dependent on parallelization. And another thing is axons carry signals at speed of 120 meters per second maximum, while electronic devices communicate with each other roughly at speed of light. This is very slow of brain. So how do we control superintelligence? There are, of course, dangers of this. If we are dealing something more intelligent than us. If we consider the obvious question that is material for many movies, how do we defend ourselves from such a power? How do we prevent possible existential catastrophe? It's like to these developments. It's likely to these developments will end up or maybe start with an intelligence explosion and threaten our existence. Then we must figure out a way to turn this explosion into a controlled detonation. Maybe this is the most important concern about this subject. Although superintelligence will become very fast after human level intelligence, we know have a distance to human level intelligence. But as we discussed before, development of artificial general intelligence to human level intelligence may be fast. In this case, we'd better already have a solution. We can look into this problem in two approaches. In the capability control methods, we basically try to limit what the superintelligence can do. Maybe by placing it into an isolated environment, and this is called boxing method. In this method, we prevent it to interact with the outside. For example, we put it into metal frames or Faraday cages, maybe, to disrupt the radio signals or any other wireless signals. Another is incentive methods. In these methods, we place the agent in an environment that have instrumental reasons not to behave harmingly, or limit its internal capacities, and this is called stunning. This may be done by running the AI on a slower hardware or low capacity memory. And the other is we can use automatic attempt detection and reacting methods by using tripwires, a system that watches predetermined actions, ports, or maybe a fake Ethernet port, like for example. In an attempt, the system may be shut down and restarted after reprogramming the agent. The other kind is motivation selection methods. This approach aims to shape what the superintelligent wants to do, dealing with agents' motivation systems and its final goals. Direct specification is explicitly programming a goal or setting rules to follow, like Isaac Asimov's laws, we can say. Indirect normativity to implicitly program the agent to discover the desired goals by itself. We leave clues, and by following that clues, the agent discovers the goals, our desired goals. The domesticity is to try to build the system to have unimportant, maybe fake goals, neutral goals, to keep them busy, for example. And augmentation is to select a system that is not super intelligent and take this system that has a desired goal, which we choose from an existing AI system, and augment it to make it super intelligent, but without corrupting its goals. And some of these methods may be or should be applied together, or some of them cannot be applied at all. We should realize that the agent we are dealing with is a super intelligent agent. And the conclusion, apart from these subjects that I mentioned, is there are many more aspects to speak to, like political influences and economical influences, hardware capacities, ethical matters, the future problems like unemployment or slavery of the agents or humans in the future, and so on. And this is a very wide topic, and that neither I have enough time and knowledge to cover. Thank you for all for listening. And if there are questions, I will try to answer.
Thank you, Murat. John, it was very informative. So, does anyone have any questions? Thank you for the links, by the way, Mohammed and Seth, to those videos.
So I have a question or statement, I guess, about, so you mentioned about like the computation comparison about like human brains and computers, but I didn't hear anything about also the power efficiency. So like the human brain is like 6 orders of magnitude more power efficient, whereas the computers are like 6 orders of magnitude faster. I didn't hear any like comparison about this point, and also about hardware that like there's other hardware being developed to address this issue, like in neuromorphic computing.
Maybe the power efficiency will be valid, but the speed is the power of brain comes from not its speed. It comes from, I think, its huge parallelity.
I agree.
All right, thank you. Let's see. All right, so Murat John, so is this something you're interested in studying more in depth?
Maybe I would like to study. I haven't decided. I haven't made my final decision yet, but recently I've read about this subject two books I have been assigned to, and I've made a research, including some articles about this. And since my knowledge about this subject is new and recent, I've decided to make my presentation on this subject because I didn't have much time, and it would be easy to get prepared, get ready. But it's one of the subjects of my interest.
Well, that's good to hear. Yeah, it's definitely an interesting subject. Even though you know, I teach in the technical field here, I really find the some of the philosophical aspects that you bring up to be the most interesting to me, like the aspects of, you know, culture and politics and stuff like that, and how do we you know, how do we control for that, and how do we, you know, because there's so many different ways of viewing the world, you know, and so yeah.
Yes, I agree you. While I was reading the books and making research, many times I've surprised the variety of the aspects of concerns and questions. But the scientists are working on it. It's good to see that.
Yeah. All right. Well, thank you very much. And so that, as far as I can understand, that ends our presentations on people who will be doing their research, literature review style presentations. So we do have time for, you know, at least 2 more presentations if anyone's ready. So I have listed for today, Seth, you've already said that you want to wait till next week, and that's fine. But I have listed for today Berk and Ismail as well, and I see Ismail, you're here, and I see Berk, you're here also. Are either of you prepared to present the ethical argument?
Yeah.
Okay. Let me stop